These are the instructions for the illusion of space question. So you need to watch this first before you start working on the question, or it won't make as much sense. So space is one of the elements of design. Other elements of design are things like line, shape, form, color. And the elements of design are what we use to make a piece of art. Real objects exist in space. They have three-dimensional form. Shapes are 2D. And often the thing that we use to make art is flat, but we're trying to make it not look flat. So we've got flat paper, flat canvas, maybe we're painting on, walls if you're doing a mural, or working on a screen when you're doing digital art. But the thing that we're working on is creating a world that's not flat. And we reproduce that world that's not flat in our artwork using all kinds of tricks. And that's what this project is about. So when you look at a work of art, how do you know what is supposed to be close and what is supposed to be far? You use what you know from the real world to understand that this tree is supposed to be closest to you, and these ones back here are supposed to be much farther away. So here's some of the tricks that artists use. To make art look like it has depth, we imitate the rules from real life. Objects overlap each other. Whatever is closest to you is in front. Position on the page. So if this is a flat page, we're looking at the entire thing. We've got the foreground, middle ground, and background. Relative size of objects if we see an object more than once in the picture. Changes in value. Value, remember, means lights and darks. And the idea of perspective. We're going to look at each one of these a little more closely. So let's start with position on the page. And that has to do with where the bottom of the object starts. So if the bottom of the object starts way down here near the bottom of the page, which we call the foreground, that means it's supposed to be close to us. If the bottom of the object starts about halfway up, that's the middle ground, that's a bit farther away, but not the farthest away in our illusion of space. And if an object starts in the top third of the page, well, then it's in the background, and it must be very far away from us. Now, if I went and touched this page, this part of the page, this part of the page, and this part of the page are exactly the same distance from my finger. But because we're pretending it's like real life, this looks like it goes farther away the farther up the page we get. So the position on the page is imitating real life. And here's an example with an optical illusion. If I asked you which dinosaur was bigger, you'd go, that one. Well, if I actually put them side by side in the drawing, they're exactly the same size as each other. But our brain knows that things get smaller, or at least they look like they get smaller, when they get farther away from you. So that dinosaur has to be bigger because look how far away our brains tell us that it is. Overlapping is the next trick that we're taking a look at. And this is actually an impossible picture unless these are made out of paper. If these were real objects, like a real jam jar and a real jelly jar and a real coffee, tea, and mug, you would not be able to line them up this way. See how the bottoms are all exactly the same spot? Yeah, that's not real. But this is just to illustrate a point. Whatever you get to see the entire object, that has to be in front. And if part of it is hidden behind something, it must be behind and farther away from you. So overlapping is one of the tricks we get from real life. And here's an example of how overlapping works. Here are several pyramids from Egypt that are different sizes and they're different distances away. And we can't tell by how big something is whether or not it's closer or not, because these are actually the pyramids of the queens of this king who made this tomb for himself. So they're built smaller. We know they're closer to us, even though they're smaller, because they overlap his pyramid. And then here's a later pyramid that's even bigger. Relative size. We use size as one of the biggest clues about how far away something is. And if we have an object, like a car or a tree, and then we see another car or a tree in a picture, and it's smaller, we assume it's not a smaller car. We assume that it's farther away. So same object, smaller, means farther away, relative size. Here's an example. Take a look at these tree trunks for this and this picture. I love the way that these are all the paint strokes in this picture and the colors too. But see how big these tree trunks are? Okay, now take a look here in the middle ground. See how much smaller these tree trunks are? And you can just get a suggestion of some over here. But the farther back we go, the smaller they get, relative size. Changes in value. And it says changes in value number 1 because there's more than one way that we're looking at changes in value. And I'm sorry, this is covered up, so I'm going to read this part. Value is lightness and darkness. So I want you to look at the mountains in this picture as I'm talking. The more intense the color is, and the more details you get, the closer it is. So this is a more intense blue color here. And the more faded it looks, and the less detail there is, the farther away it is. So see these mountains back here are much more faded color, and there's less going on. So this says less intense color equals farther away, and the part that's covered says less detail equals farther away. So what's going on here is called aerial or atmospheric perspective. If you've ever sat in a room where the sunlight's coming in and you look through the shaft of sunlight and you see all kinds of sparkly things floating in it, that's dust. So imagine kilometers of that dust and particles of moisture in the air between you and the thing you're looking at. It creates a filter that gives you this look. Here's another example of it here. And it's called atmospheric perspective. Sometimes it's called aerial perspective because it has to do with air. And people in animation often use this trick to try to show distance in outdoor scenes. So you'll notice in both of these scenes that the closer the layer is to us, the darker it is, and the more faded the color is, the farther away it's supposed to be. Now, changes in value number 2. So not talking about shading at great distances, we're talking about shading on an object. So if you look at one object and you're thinking about it as a 3D form and how the light hits the form, then imitating how light would hit a form gives you a change in value from highlights to medium tones to darker shading and cast shadows. This kind of change in value shows that this object is in 3-dimensional space and it's not flat in 2-dimensional space. So here's 2 examples of a famous picture called Girl with the Pearl Earring. And this one has much greater range of changes in value, especially along the face, than this picture here. Perspective lines are something that you're going to be doing. You're going to be doing 1 and 2 point perspective booklets. And the lines that go into the distance show a mathematical way that you can reproduce the idea of things getting smaller as they get farther away from you, at least the illusion that they get smaller as they get farther away from you. Because it'd be kind of freaky if you actually got smaller if they went farther away from you. Perspective lines count on the fact that things in the distance look smaller and closer together, and this change is mathematical and predictable. 1 point perspective takes those lines to one vanishing point. Interior spaces are often shown with 1 or 2 point perspective. It's a system that makes it easy to decide how much smaller an object should be as it moves farther away from you in a drawing. 2 point perspective is a similar idea, except you're using 2 separate vanishing points off to the sides instead of 1. So let's take a look. There's going to be some examples, and I'm going to walk you through the methods that I see and exactly where I see them. And then you're going to try an example where you do this and you put it in writing for me and hand it back in for the question. So looking at this picture by M.C. Escher with its little flying fish, which methods were used to create the illusion of space here? I'm going to go through each one. Do I see position on the page? Well, not so much because they're flying. So I've got a big one way up here And I've got smaller ones down there, so I do not see position on the page. Do I see changes in value? Yes. There is a lot more contrast on this one that's closer to me, and there's a faded look and a lot less detail on the ones that are farther away. So yes, I do see changes in value. Do I see overlapping? Absolutely. This is one of the ones that I can see everything, so I know that it is closer to me, whereas these small ones back here are being overlapped by multiple different flying fish. Perspective. Do we have a 1-point perspective here? Possibly. It looks like there could be perspective lines going to a vanishing point that's off here. This one is a maybe. Relative size, meaning do I see multiple objects? Some of them are bigger, so I know that they're closer to me. Absolutely. So this is the biggest one. I think this one is closest to me. And this one down here is fairly close to me because it's larger than some of the other ones. As we get into here, where everything is very overlapped, they get very small. So I know that the small ones are supposed to be farther away from me. So I've named the technique and I've described where in the picture I see it. So let's take a look at another one. So look at this picture for a minute before I start talking, thinking about which of these do you see in this picture to create the illusion of space. So this is a picture of haystacks by Claude Monet from the Impressionist period. So here's a haystack, here's a haystack. We've got the field, some trees in the background, and some sky. Position on the page. Is that something where they're trying to use that to create the illusion of space? I think yes. See how this haystack starts near the bottom of the canvas? And it's supposed to be close to us? This one starts in the middle of the canvas, so it's supposed to be farther away. And then there's these objects that we can't really tell what they are, but I think they probably are trees that are starting higher up the page, so those are supposed to be even farther away. So I see position on the page. Do I see changes in value? Perhaps a little bit. There is a lot of detail in the objects that are closest to us and less detail in the background, but that one's not as strong. Do I see overlapping? Yes, this haystack obviously overlaps other parts of the picture. They are coming out from behind the haystack and they're slightly hidden. Do I see perspective? No, I do not see 1-point perspective. Do I see relative size? Absolutely. I have two objects, and I have no reason to think that one is a little haystack and one is a big haystack. I think that this is a close haystack over here, and this is a farther haystack that is smaller on the page. Now, this is your turn. You're going to be working with this picture, painting of New York City on a rainy day, and there are more than 3 methods in this picture. So you're going to pick any 3 that you can justify in the picture, and you're going to describe how it's used to create the illusion of space. So you have to name it, and then you have to say where you see it in the picture. If you don't say where you see it in the picture, then you're not showing that you understand the idea. All right? So position on the page, changes in value, overlapping, perspective, relative, size. There's more than 3. Pick the 3 that are the most obvious to you.